Oh no, I didn't go back to playing. That's what No, it was my 17, but I just turned off the first one, but that's right. But I put one like we put early in actually that maybe I'll check this.
Great.
I woke up. Yeah, but I was at 2. Check last day.
All right, guys, welcome back. Hope you guys had a nice break. So let me talk a little bit about first semester versus this semester. So first semester, we did a lot of trig, and all that trig is going to be really useful and helpful if you decide to enter AP Calculus, AB or BC. For this semester, a lot of these topics you may see in future courses like BC Calculus or Stats, but a lot of this semester is not going to be directly applicable for AP Calculus AB. So just kind of let you know, we're hitting a lot of kind of separate topics. Unlike first semester was more connected, everything was trig related. But here we're going to be jumping from one topic to the other. That may be good in the sense that if you struggle with one unit, then you get a brand new start the next unit. So there's not as much connection between these units. So that's just the nature for this semester, just to kind of give you a heads up. So we're going to start off with matrices. Actually, well, let me take that back. There will be some trig for within vectors, but by and large, you're going to feel like all these topics are kind of disconnected. Okay, so we're going to start off with, so this unit is matrices. I think today is going to feel pretty easy. The multiplication is going to feel a little messier, but it's not too bad. We just have to practice with the processes. I think the quiz shouldn't be too bad either. I think the hardest thing about this unit are the word problems, and we're going to reach those word problems much later. It'll be after our holiday weekend and leading up to the test. Okay, but you should find this, I think, pretty straightforward, pretty easy. Okay, and also on the back of your calendar, there's a good summary sheet, so we can go back and it'll be a good resource as we're reviewing our topics through this unit. Okay, so let's go to page 1. Okay, so matrix is a rectangular array of numbers. We're going to use it to solve systems of equations, which we're going to see next week, and to record data. So think about Excel spreadsheets. So the types of problems that we're going to be able to solve, we're really going to see the application of it when we get to the word problems. But for now, you can just think of it as like a 2x4 or 2x6 set of numbers, and just organizing those numbers. So that's what we're going to right now, just kind of be working on vocabulary and also being able to add and subtract matrices. Okay, so here's example of a matrix. This is a 2x3 matrix. And that's the dimension of this particular matrix. So we can say dimension is the size of a matrix. Measured as rows followed by columns. So rows goes from left to right, and columns go from top to bottom. So 5, 0, -1, this is part of row 1. -3, 1, and 9, those are numbers in row 2. 5 and -3, that's column 1's values. 0 and 1, that's column 2. And -1 and 9, that's column 3. So we say this is a 2 by 3 matrix because we have 2 rows and 3 columns. Two rows by 3 columns. Okay, any questions with that? Okay, so the elements are the values inside these matrices or inside the matrix. Okay, so the element are values inside the matrix. The locations are described as row number followed by column number. So let's say I want to find the element in this location. Okay. Now, this looks like 13, but it's really find the element in matrix A, the value that's located in row 1, column 3. So which value is located row 1, column 3? Good, -1. So if we read this as 13, then it feels confusing, right? Because there's like, what does that mean? But you have to understand that there's an imaginary comma between the 1 and 3. So the value in row 1, column 3 is going to be this number here, -1. Yeah, any questions? Okay, so next example here. Matrix B is known as a column matrix because it's a matrix with only one column. So this is column 1, because that's the only column there is. This is row 1, row 2, row 3, row 4. So what do you think the dimension of this matrix will be? Right, row followed by column, 4 by 1 matrix. Four rows, 1 column. Okay. So what do you think a row matrix is? Matrix with only 1 row. Okay. So see if you can create a 1 by 3 matrix. You can fill it in with any number you want. Let's see if you can create that, and we can compare to see if we agree. A 1 by 3 matrix C. Your numbers will be different from mine most likely, but mine is a 4, 6, 9, but it should be that dimension. Yeah. 3 columns and only 1 row. And what do you think, what do you think, the definition of a square matrix is? Yeah, where the row and column are the same, yeah, so it could be a 3 by 3, it could be 2 by 2, it could be 4 by 4. So see if you can create a 4 by 4 matrix D. Again, the numbers can be anything you want. Yeah, so any numbers that you can fill in is fine, but it should look like this. It should have 4 rows and 4 columns. Okay, next page. Adding and subtracting matrices. Everybody okay? So you're going to find that adding and subtracting matrices is very intuitive. What you think is going to happen is what's going to happen. So addition and subtraction can only be done, however, with matrices of the same size or dimension. Scalar multiplication can be done with matrix of any size. So scalar multiplication just means if I have a number in front of my matrix, I'm just going to make that number distribute through and multiply through. So let's say I want to add matrices S and U together. Are these the same dimensions? They're not. So we can't match row 1, column 1 with row 1, column 1 with the other. I mean, we can, but we're going to run out of numbers, right? So, so here, this one is not possible. Okay, so S minus T, we're going to take each element within S and subtract the corresponding value in matrix T. Okay. So if we set it up, it may look something like this. Here's my matrix S. Here's my matrix T. And I'm just going to subtract each element. So I'm going to end up with the same dimension as I started with. Okay. This is a 2 by 3 matrix. Once I subtract the 2 matrices, I should still get a 2 by 3 matrix. Now, what do we have to be careful about if we're subtracting matrices? What could trip us up? Yeah, we got to keep track of our negatives, right? So this minus sign is not the same as this minus sign here. So we have to sometimes remember that we may have keep track of our multiple minus signs. So what's gonna be the first row, first column value? 2 minus -5, which is what? 7. Okay, so go ahead and try that. See if you can find the corresponding resulting matrix. Just make sure that we gotta keep track of our additional negative that is going to potentially cancel out the negative that's already in the second matrix. Okay, all right, let's compare our results. Seven, 3, 2, -11, 6, -12. Any questions there? Okay, what do you think we will do here if we do 2 times t?
Multiply by 2.
Yeah, multiply every element by 2, right? Every value by 2. So, yep, try that. T is a 2 by 3 matrix. You're going to still end up with a 2 by 3 matrix. You're just going to end up distributing that 2 to every value or every element inside matrix T. Row 1, you should have -10, -8, and 2. Row 2, 14, -16, and 8. Okay, what do you think we can do with 1/2 mu?
2. Or you divide by 2.
Yeah, divide by 2 or multiply by 1/2. Okay, so either way, we'll get the same thing.
So do you put it in decimal form?
You can, but if you leave it in fraction form, that's fine as well. Yeah, so if it's an exact value, then either is fine. But if it's like 1/3, rather than putting 0.333, you'll just leave it as 1/3. But in this case, 9/2 or 4.5, they're both equivalent, so they're both fine. So if I multiply everything through by 1/2, I get 9/2, -2/2, -3/2, and 0, because 1/2 times 0 is still 0. Okay, so 9 halves, -1, -3 halves, and 0. Okay, next up, use matrices A, B, and C to solve for X. I think the first one is pretty self-explanatory. Just multiply 2 through matrix B. Okay, here, let's solve this equation first. If I want to solve for X, what's X equal to?
C minus A.
C minus A. Okay, so we're going to simply subtract A from C. Go ahead and try that. Can we do it? Are A and C the same dimensions? Yes. Okay, so go ahead and set that up. Make sure you keep track of your negatives. Matrix C is 2 by 2 matrix. Matrix A is a 2 by 2 matrix. I put a minus sign in between, but I want to make sure that I'm keeping track of all my negatives. So I end up with -5 and 8 in first row of matrix X, and then second row 6 and -13. Okay, addition, subtraction, scalar multiplication, pretty easy. Even if I didn't present this to you, if you're just trying to figure it out, this is probably what you would do anyways. So it's a multiplication between matrices that's going to feel a little messier. We have to kind of go through each step by step, but we should find this pretty easy, pretty straightforward. Okay, so your classwork is going to be page 5. You guys are going to work individually through this, but after a few minutes, I'll go through each problem and then let you guys continue working. Okay.
Page 5.
I'm sorry. My page is different here. Page 4. That I was looking at my key. Okay, so sorry, page 4. Yeah, I'm going to give you a few minutes to get started, and then I'll show the answers and I'll go over it. And then if you have any questions along the way, you can correct it, or if there's any mistakes you make, you can correct it, or if you have any questions, hopefully I can clarify it, but hopefully you'll find at least the top half pretty straightforward. The bottom half, there's some rearranging that we may have to do to solve for X, but really you want to just solve for X first, and then you can fill in the matrix matrix names with the actual values. Again, the 2, 2, and 3, 1 doesn't mean 22 and 31. This means row 2, column 2, and this means row 3, column 1. I'll walk around and see how you guys do. Okay, so number 1 is 2 by 2 matrix. Number 2 is 3 by 2 matrix. Number 3, the elements in row 2, column 2 is 36. And the value in row 3, column 1 is negative 15. Okay, 5 through 9 should feel pretty straightforward. But when we get to 10 through 12, you may want to solve for x first before you start replacing all the elements for the matrix. It's a fraction statement. check your answers, 5 through 9. Number 9, you could do two different things. You can add t plus s together and then multiply through by 1/2. Or you can multiply each of the individual matrices by 1/2 first and then add the rest together. So it's up to you. Either way is fine. Okay, I'll talk about the setup for 10 through 12 in detail, so that you can make sure you're on the right track, but let's make sure we're okay 5 through 9 first. Okay, does anybody still need 5 through 9? Let me talk about 10 for a moment here. I'll put this up again if some of you are still needing to look at this. So number 10, it feels messy with that 1/3 x, but I want to solve for x. So what can I do to both sides to get rid of that 1/3? Yeah. Or if I want to move that 1/3 over to the other side, dividing by 1/3 is the same thing as multiplying by the reciprocal. So I can multiply a 3 through both sides of the equation, and that will allow that 1/3 to go away. And so x is equal to 3 times q minus r. So that feels easier. Now you don't have to deal with a fraction. You can subtract q and r first and then multiply by 3, or you can do 3q minus 3r and then merge those together. Okay. I just want to make sure you guys have the setup so that the rest should feel pretty straightforward. Here, if I want to solve for x, I can just add x to this side and subtract t to the other side. So 3s minus t is equal to x. Solve that basic equation, and then you can replace the matrix with the values. Okay. Number 12, I would distribute the 2 through, and then you can just subtract and divide the rest over. So actually, you can do multiple things here. You can maybe multiply by 1/2 if you want. Yeah, up to you. So if you want to do 2q minus 2x equals negative t. Let me just make everything positive here. 2q plus t. Actually, do we have an issue here? Are q and t compatible? No, right? Q and t are not the same dimensions. We can't flip a matrix and make them add together if they don't have the exact row and column matching. So here, this one is not possible. And then for 13, a scalar multiple just means you want to put a number outside of your matrix, and then multiply through. Okay. I'll show that. I'll go through 13 in a moment, but I want to see how you guys do 10 through 12 first. So for number 10, I subtracted Q minus R first, and then I multiplied through by 3. For 11, I did the scalar multiplication for S, and then subtracted T. Yeah, make sure that you do 3S first before you subtract the T, right? You want to get this cleaned up before you deal with the two matrices subtracting each other.
I'm confused on that 13 to work on. I don't know.
The word problem?
Yeah.
Yeah, I'll go over that. Okay. Are we okay with 10 and 11? I'll leave this up for a moment and I'll go over 13 in detail. Okay, everybody okay with 10 and 11? Okay, let's look at 13. Okay, Jessica took her two children, to the community swimming pool. Yeah, once a week for 6 weeks. The daily admission fees are $4.50 for a child and $6.75 for an adult. Write a 1x3 matrix. So here's a 1x3 matrix. 1 row, 3 columns. We have to fit this into this matrix here. So what do you think each of these matrix could represent, or each of these values could represent? Yeah, the mom and the 2 kids, right? So 450 for the first child, 450 for the other child, and then the mom 675. Now this is going to be the cost per week. So times 6. So there's the scalar multiplication. The scalar multiplication is going to come outside of your matrix. Yes.
So are we gonna be able to use a calculator?
Yes, you'll get these calculated. Well, to some extent, I think the multiplication portion requires us to have to do this by hand. So yes, eventually with a test, but for the quiz, we may be doing it without a calculator. But the numbers are going to be a little bit smaller. And also, I'm more concerned about the process than the actual value. So if you mess up because the numbers are messy, that's okay, as long as I understand that you get the process and that you're going through the correct process. I care more about the process than making a mistake here because you just added or subtracted wrong. Okay, so what do you think we're going to do here now? How can we find the total cost? Yes, multiply 6 through every term and then do what? Add them together. Yeah. Okay, so over the course of 6 weeks, $27, $40, 50 cents. Add them together. The total cost that they'll have to pay over the course of 6 weeks for the 2 child and the mom is $94.50. Okay, tomorrow we'll pick up with multiplication. Go and get your phones. Yes. Happy that we could.